Yes, I hope you could able to see the screen.
Yes, sir.
Yes, the students, the way with which we
Yes,
are
sir.
proceeding. Last time I discussed the part one.
Yes, sir.
Are you understanding the things?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
All have not replied.
Yes, sir.
Yes, sir.
Okay, see, don't ask me to ask again and again to reply. See, yesterday we have discussed SP hybridization. I want to know the answer from you. What is the example for SP hybridization? Not clearly audible.
Cl2.
Right, BCl2. Okay, next hybridization that you have discussed is sp2. I want your help. What is example for sp2 hybridization?
BF3.
Yes, BF3 or BCl3. Very good. Yesterday again I discussed the one more hybridization. That was sp3. What's the example for sp3 hybridization?
Methane.
Other than that,
Silicon trichloride.
silicon tetrachloride.
Cl4.
Yes, SiCl4. Tri means 3, tetra means 4. Simple, basic. Okay, fine students. Today we are discussing further additional hybridization. Interesting hybridizations those are. And the hybridization is sp3d. Total, how many orbitals are involved in this sp3 hybridization?
3.
How? Total orbitals. Don't see P as a one. P is Px, Py, Pz. All are orbitals. Total orbitals.
5.
Yes, 5. See, where is the confusion that I am feeling? That you are thinking that P is a one orbital. See, Px is a one orbital. Py is a other orbital. Pz is a third orbital. Then what is this P? What is this collection of all these three? It is sub-level. Level means principal cell. It is sub-level. P is a sub-level. D is a sub-level. S is a sub-level. DE can be splitted in 5 orbitals. So orbital, if concept comes, then it is Px, Py and Pz. 3 orbitals are there. When we say P orbital in general, then any of these orbital. But when we say a P, a sub-level, then all those 3 orbitals are going to come. One more example, if I consider, say, the d orbital, this example here, d orbital means it can be dx square minus y square, it can be dz square, it can be dxy, it can be dyz, it can be dxz. All these 5 orbitals are there in which d subcell. Only one when we represent, then any one among these will remain present. If I have to make this concept clear, pay attention now neatly. When I say P, then it can be Px, it can be Py, it can be Pz. But when I say P3, then all 3 orbitals will be there. When I say it is a P2, then only 2 orbitals are there. Any 2 orbitals, maybe Px, Py or Py, Pz. When I say only P, then at that time only one orbital will be there. In case of the hybridization, any one orbital will be there. Is the confusion about the number of orbitals which I noted, is it clear?
Yes, sir.
Yes, sir.
Yes, you are confused. Now I think it is clear. Number of orbitals in which we are interested, and that number of orbitals signifies number of bonds. So there will be 5 bonds. We want such a molecule. We want such a chemical where 5 bonds are there. Yes, I want your help now. Which example will you suggest me for 5 bonds?
PCl5.
Very good, brilliant answer. So let me
PCl5.
discuss. Yes, let me discuss PCl5 as an example. So yesterday our point was there, no? First point, that's an example. That is the PCl5. So how many bonds are there? In these 5 bonds are there. So expected hybridization that we will be with, that already we have discussed, that is sp3d. It's expected. Let us see whether it is a reality or not. For hybridization explanation, we want electronic configuration. Whose electronic configuration I will focus now? Electronic configuration of
Central atom.
central atom. Who is central atom here?
Phosphorus.
Exactly. Very good, very good, very good, very good answer. See, other students also have to reply, not only the few. It is phosphorus. Atomic number of phosphorus is 15. So its electronic configuration, I do not write completely. I mention here the noble gas. I want your help. Before 15, which noble gas is there? What is the atomic number? 10. The element with atomic number 10, noble gas. Which is that?
Neon.
Exactly.
Neon.
Neon. Yes.
Neon.
After neon means after 2p6, next orbitals will be there. Which orbitals are there after 2p6? 3s. How many electrons will be there? 2 electron. Then 3p. How many electrons?
3.
Brilliant.
Three.
Three electrons. Okay. Let me represent it in terms of the block. So I represent here 3s. I represent here 3 orbitals of 3p. And addition to this 3p, one more orbital may possible. Electrons are not there, but I want to consider that orbital which is present in that shell, which is present in that third shell. Which orbital it is? After
3D.
3p? Yes, 3D. How many electrons should be there in 3D? 0. No electrons because 15 electrons are over. So here 3D is there. Let me represent that 3D orbital also. Yes, 3D orbitals means how many will be there? P means 3 orbitals. D means how many orbitals will be there? Possible?
5.
Yes, 5. 1,
5.
2, 3, 4, and 5. Yes, 5 orbitals, those are represented. So if I have to write now the electronic configuration for phosphorus, where atomic number is 15, then neon already is completed. After that, in 3s orbital, I need to show 2 electrons. And in 3p orbital, first electron, second electron, third electron. I want your help. I represented this 3 electron in 3 different orbitals. I had not preferred 2 electrons in one and 1 electron in other. It is as per which principle? It is as per which principle or which rule? I want your help.
Hans.
Yes, Hund's rule of maximum multiplicity. Therefore, I represented these 3 unpaired electrons. Okay, in d orbital electrons are not there. Now, here how many unpaired electrons are there? Unpaired electrons?
3.
3. Unpaired electrons are 3. So we were expecting 3 bonds. So we were expecting PCl3. Yes, PCl3 also is possible by the simple. But hybridization for PCl3 can be what? The different one. I'm talking here about the PCl5. So here 3 unpaired electrons are not more useful for me. I want 5 unpaired electron. Help me. How can I make 5 unpaired electrons available? What shall I do? In order to make 5 unpaired electron, what will I do?
Excite from 3s to 3d.
Yes, excitation of electron from 3s orbital to one of the 3d orbital. Brilliant answer. So I do that now. I remove this electron from 3s and I excite it to one of the 3d orbital and I represent here. And now whatever my aim was there, 5 electrons should be there, unpaired electrons. That is what achieved. Okay, it is a one step, but afterwards important step is there. After excitation of electron, what is the next step? What is the next step? No, could not hear. You are answering, but I could not hear that answer. After excitation, next step is very important one. That's the point that we are discussing. I want your help. After excitation, next step.
Hybridization.
Yes, hybridization. Which orbitals will hybridize? Wherever electrons are there, those orbitals will hybridize. So I represent that hybrid orbitals. See here, s orbital, p orbitals, and d orbital. sp3d. Hybridization will be sp3d. What is that hybridization? Hybridization is a mixing and recasting or redistribution of the energy of these 5 mixed orbital. So after hybridization, that individual orbital does not remain with its identity. An orbital can't say, I am a s orbital or I am a p orbital. No, all are mixed now. All are united, and accordingly whatever the shape is there, that shape all have to accept. S orbital can't say that I am spherical, and p orbital also can't say I am dumbbell. Its shape also will get distorted, but more specificity is there in that the dumbbell shape arrangement. Proper alignment is there, bond formation is there, and therefore those will be splitted or those will be divided in the dumbbell shape. So 5 orbitals will be there. 5 dumbbells I will be with. So how can I arrange those 5 orbitals? I give you the answer. I want the reply from you. What is the shape of that? Out of those 5, 3 will align in one pattern and 2 will align in different pattern. So 3 will align in one pattern means as like sp2 hybridization is there, one orbital, second and third. It is what? Fan-like shape. It is planar. Angular separation is 120 degree here in these 3 orbitals. And other possibility is there, the 2 are there. Those 2 will arrange in which manner? They will perpendicular to these 3. Here is 1 and below that is there actually. I represent it now here. It's faint and here somewhat dark. See, here is 1 orbital. So upside 1 lobe will be there and downside 1 lobe is there. So those orbitals, how many are there? 2. How are they? Linear. I'm talking about out of the 5, 2 orbitals. Linear. How is their arrangement? If you say the one straight line is linear. And what is the angular separation? 180 degree is the angular separation. I want your help, students. What is the angle between this blue lobe and red lobe? This angle. I have given answer also there. What is this angle?
90.
90.
Brilliant. Yes,
90
absolutely.
degree. 90.
Is 90 degree. Yes. What is this angle? Angle between 2 red lobes. This angle.
120 degree.
Exactly. 120 degree. Okay. One more reply you give me now. What is this angle? Angle between blue lobes.
180.
180.
One.
Yes. Very good. 180 degree. See, by the answer of these many questions, now concept is clear. How is that sp3d orbital is? And I said already that sp3d 5 orbitals are there. Those are divided in 2 parts. One, 3 orbitals and other 2 orbitals. To these 2 orbitals, we say as axial orbitals. And to these 3, we say as equatorial orbitals. Okay. Now let us understand what is the meaning of this equatorial. Equatorial means perpendicular. Have you heard the word equatorial? Equator, equatorial level. Then many say it's horizontal. Actually, that horizontal came why? Because whatever the perpendicular that we consider as axis, may you consider the axis perpendicular to the level of the ground where we are there, or axis of the earth you can consider any. Perpendicular to that, whatever we will see, that will be the horizon. And that horizon is equatorial. In that way we can consider it's equatorial. Equators which are north and south, I'm not talking about equatorial means that's a horizontal position. But in order to understand horizontal, we should know axial. What one can say, axes are there. Means if you study the axis of symmetry, means plane of symmetry or the molecular symmetry in particular, next year it is in your syllabus, then concept will be the more clear. But timing, remember, here 2 axes are there. Means if I consider one line, I represent that line by dot. See here, this line. I want to consider this line. Means I am holding this one blade of the fan. Here, this blade of the fan. And if I rotate the molecule by 180 degree, I write it neatly. See here, it's here. 180 degree, I will get similar structure. If I consider the axis, other axis as this one, this axis, up down axis, this axis passing here, this axis. And if I rotate the molecule, then by rotation of how much degree I will get similar structure? Can anybody guess? If I hold up and down and if I rotate the molecule, by how much degree rotation I will get? Fan after rotation of how much degree get the similar structure?
120 degree.
Yes. Are you understanding, Shivam? How is the answer?
Yeah.
Okay. Other students, are you understanding?
Yes, sir.
Okay, it's a 120.
Yes.
It is a 180.
Yes, sir.
Yes.
Smaller the angle by which we rotate the molecule, that is a main axis. That's a principal axis. This we say as organic chemistry might have studied. It's a C3 axis. And this axis is a C2 axis. Higher the order or lower the angle by which you rotate, that is a main axis or principal axis. So it is now our principal axis. Up down is our principal axis. So if this is a principal, is a main axis, then the orbitals whichever are there, this orbital and this orbital, these are the 2 orbitals. What are those 2 orbitals? These are axial orbitals. And the orbitals which are perpendicular to that axis, means this orbital, or this orbital, those are equatorial. Students, are you following these terms, axial and equatorial?
Yes,
Yes,
sir.
sir.
Yes.
Yes, sir.
So here, all orbitals are not equivalent. Important term, interesting term that you are studying here. When we were considering sp hybrid orbital. Likewise, represent was there. Here, both orbitals are equivalent. So let you consider the approach from here or approach from here, anywhere, or both orbitals are equivalent, uniformly oriented, because each one is separated by 180 degree. So these are equivalent hybrid orbitals. Equivalent. See, I'm not saying equatorial. Equivalent. Equivalent means same. Now I want to ask you the question. If I consider sp2 hybridization, it's a one lobe, second lobe, and third lobe. In this sp2 hybridization, what do you think? These all orbitals, orbital number 1, orbital number 2, and orbital number 3, are they equivalent? What's your answer? Are they equivalent? Are they having equal separation, equal orientation, equal opportunity, equality? If equality, then equivalent. If not, then non-equivalent.
Equivalent.
Yes.
Yes, absolutely. Those are equivalent. So here also the question not came when we had a discussion previously. Now I represent the next orbital. That is sp3 hybridization, sp3 orbital. Just wait. Okay, it considered as the image now. Okay, students, I represent here now. sp3 hybrid orbital. One lobe of sp3 hybrid orbital, second lobe, third lobe, and fourth lobe is behind. Just wait. Let me see who wants to enter. Tejas. Yes. I want your answer now. Here, orbitals are equivalent or not equivalent. What do you have to think? Whether separation of each orbital is equal or not. Orientation is uniform or not. Equivalence is there or not. Equivalent or non-equivalent.
Equivalent.
Yes, brilliant answer. Equivalent is a correct answer. Equivalent. Now, whatever I am discussing, that's sp3d hybrid orbitals. And these sp3d hybrid orbitals, what happened? Those orbitals which are drawn went out. Okay, let me draw again. It's a one lobe, second lobe, third lobe. This is the in one line you can consider, or one plane. Those are all those three orbitals are there. They are in one plane, and other two orbitals are there. Those are represented here upside, and other one downside. And dot you can consider. Yes. Now tell me, this sp3d hybrid orbital, your orbitals are equivalent or not equivalent?
Not equivalent.
Yes, not equivalent is the correct answer. These two belong to one category and these three belongs to other category. These three are, what is red are there? Three are equatorial or axial?
Equatorial.
Yes, equatorial.
Equatorial.
Yes, very good. And accordingly, you will understand these two are axial. Okay, that's a hybrid orbital, its diagram. Our point of interest is to describe the PCl5 molecule, sp3d hybridization, PCl5 molecule. For that, in hybridization, actually what happens, that we have to discuss now. So sp3d hybrid orbital I represent is the one, second, and third. Yes, it is a upside, and other one is what, the downside. It is sp3d hybrid orbital. With this, which orbitals will overlap? Our other atom is chlorine. I want your help. Chlorine atomic number is 17. Now, which orbital of chlorine will be there, which will overlap, which has unimpaired electron, whether p orbital, one of the p orbital, or s orbital? Waiting for your answer.
P orbital.
Yes,
P orbital.
it's a p orbital which has unimpaired electron. Let it be the pz orbital or any orbital. So that pz orbital of chlorine will interact. So orbitals of chlorine I represent by the other color. See here, it's a p orbital of the chlorine where unimpaired electron is there. Only one orbital I am representing now. Here is a p orbital of the chlorine where unimpaired electron is there. Here is also p orbital of the chlorine where unimpaired electron is there. P orbital of the chlorine where unimpaired electron is there. P orbital of the chlorine where unimpaired electron is there. So due to which what will happen? That's 5 unimpaired electrons which were there on phosphorus. Here is one unimpaired electron, second, third, fourth, and fifth. They will overlap with the unimpaired electrons from chlorine. Electron from chlorine, electron from chlorine, electron from chlorine. It's electron from fifth chlorine. So we will get 5 bonded molecule. So after this overlap, in true sense, this orbital will become larger. This orbital will become larger. this portion also will become larger here also. But it's a cluster kind of arrangement will be there, and this portion which is not overlapping will be what the relatively smaller. If I have to represent that structure, then I will consider phosphorus is at the center, one chlorine, second chlorine, third chlorine. They are of one category, and other chlorines will have of other category, chlorine and chlorine. So I represent the chlorine atoms. See here, chlorine. So this is the structure for the PCl5 molecule. Now we concluded here non-equivalent orbitals are there. Why should we study this non-equivalency? It is important for the bond length. The orbitals which are the same culture, same bond length remain. Means whatever the bond length is here, in case of the PCl bond, say it is X. Same bond length will be here. Same bond length will be here because all are equivalent. And if I consider the other, that's axial bonds, the bond length if I consider is Y. Here bond length if I consider as Y. I want to know your imagination or your guess. What do you think? X will be greater than Y or Y will be greater than X? Certainly, bond length will not be equal because culture is different. In PCl4, in case of BCl3, in case of BCl2, in case of SiCl4, bond length was same. Equivalent orbitals where there is bond length will differ. 3 bond lengths will be of one category and 3 will be of other category. Now, which bond length will be the larger? Okay. If you have to answer this question, shall I give the hint for that?
Yes, sir.
Yes. See here. 2 kinds of
Yes,
orbitals are there. Yes. Axial, and axial. Think about axial point of view. I want to consider this axial orbital or this bond. You have to ask yourselves, this bond experiences repulsion with whom? This bond will experience repulsion with this bond. This bond will experience repulsion with this lower bond. By the way, that bond will experience repulsion due to other same kind of bond. Why repulsion? Because electrons are here in these bonds. Electron has to quarrel. Electron has to what? Repel. So here what are you finding? 2 kinds of repulsions are there. One repulsion, 90-degree repulsion, and other 120-degree repulsion. I want your help now. How many 90-degree repulsion these PCl bond experiences?
2 times.
Right. 2 times 90-degree repulsions are there. 2 90-degree repulsions are there. Which one? This one and this one. Students, are you following what I'm saying?
Yes,
Yes,
sir.
sir.
Yes, sir.
Yes. These are 90
Yes, sir.
repulsion.
Yes.
Yes. Very good. Now, how many 120-degree repulsions are there to this bond?
1 time.
Okay. See, this bond and this bond, 120 repulsion. Imagine properly. It is right. It is 120. Is there any further 120 repulsion possible? This bond and this bond. What is the angle?
120.
Yes, 120-degree. Now, how many 120 repulsions are there?
2.
2.
2 times.
It is a It is a study of this equatorial bond. It is regarding whom? About equatorial bond we are discussing. Equatorial bond experiences 2 90 repulsion and 2 120 repulsion. Now I want to discuss the axial bond. I represent the structure newly. Here, see, this one is upside and other is downside. Yeah, this structure. Now I am talking about this axial bond. It is a one axial bond, second axial bond. How many 90-degree repulsions are there? For axial bond, how many 90-degree repulsions are there? It is 1. Likewise, how many are there? Yes, 3 90-degree repulsions are here. And how many 120-degree repulsions are here? To this bond, is there any bond who makes 120-degree angle?
0.
Yes, there is no bond. Absolutely. So it is what? 0. It is the analysis of bond, equatorial bond and axial bond. Now we have to think about which will be stable or where close approach. If repulsion is there, then they will go away. Where the more repulsion is there, those atoms, chlorine atoms, will not come near towards the central atom. In case of equatorial, 2 90-degree repulsions are here. And in case of the axial, 3 90-degree repulsions are there. 90 degree is relatively less degree. So close approach, 90 degrees is a close approach compared to 120 degree. And it is a very important one. While discussing the stability, we focus mainly on 90-degree repulsion. Where more 90-degree repulsions are there, there will be the more repulsion. So where more 90-degree repulsions are there, in case of axial or equatorial? Yes. In case of axial, more 90-degree repulsions are there. Students, are you understanding what I'm saying?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
More 90-degree repulsion means the atom, say the chlorine atom. Now I am paying proper attention to this chlorine atom. This chlorine atom can't come more closer to phosphorus compared to whom? Compared to this chlorine atom. Here chlorine is there. This chlorine atom, sorry, not this, equatorial. This chlorine atom, which can come more closely. I represent this again. We concluded axial bond where more repulsion will be there. Two kinds of bonds are there in case of the PCl5. Phosphorus is at the center. Here one chlorine. Second, third. I want your help. These are equatorial or axial?
Equatorial.
Equatorial. In addition to that, there are axial chlorines. We noted that here 3 90-degree repulsions are here, and here only 2 are there. 90-degree repulsion. Where more 90-degree repulsions are there, that orbital will experience more repulsion. So what is happening? This bond, phosphorus chlorine bond, experience more repulsion, due to which what happens? The equatorial chlorine, this chlorine is relatively closer to phosphorus, and axial chlorine is relatively away from the phosphorus. Now I ask you the simple question. Out of this axial and equatorial, which bond length will be larger?
Axial.
Yes, axial bond length will be larger. So previously I said no, I consider it is X bond length, it is X, and axial bond length I consider as what? Y. Axial bond length I consider as Y. So I am asking question to you. You have given correct answer whether X is greater than Y or Y is greater than X. What is correct?
Y is greater than X.
Yes.
Y is
Greater than X. It is a conclusion. It is understanding of PCl5 molecule. So which points will you include? First point, help me. What is the first point? Example. Which example?
PCl5.
PCl5.
Yes. Second
PCl5.
point.
Electronic configuration.
Right. Third point.
Hybridization.
Yes. Very good. Hybridization. Fourth point. What is the fourth point?
Diagram.
Yes. Diagram. Fifth point. That's a bonding. How the overlap takes place. And here, last time it was not point of discussion. We have discussed equivalent and non-equivalent orbitals. That point was discussed. And here, 7th point, you can say structure. And in the structure and bonding explanation, you can say this axial bond is larger than the equatorial bond. By the way, what is the bond angle between the axial bond and equatorial bond, and equatorial bond? All the things you have to answer. Yes, students, is this PCl5 molecule clear to you now?
Yes, sir.
Yes, sir.
Yes, sir.
Here main point was
Yes, sir.
equivalent and non-equivalent orbitals. Similarly, other hybridizations are there. sp3d2. I don't give the all for you as a work. sp3d2. It is better, I think. sp3d2 you could able to do. Same point. How many orbitals are there total? Means how many bonds will be there? How many bonds?
6.
Yes, 6 bonds are there. sp3d2. Can you give an example? Example for sp3d2? I had given a hint.
SF6.
Brilliant answer. SF6. How logically you will think? Phosphorus can form 5 bonds. Next element is sulfur. Atomic number 16 can form 6 bonds. SF6. The way with which I discuss here, I you have to explain the octahedral structure. But here, equivalency and non-equivalency you can discuss. But actually all bonds are equivalent because octahedral structure means what? A square pen whether one is upside or downside. So if you consider these 6 bonds, 90 degree, 90 degree, 90 degree, 90 degree, everywhere 90 degree separation you will find, except this upside. But separation between nearest orbital is what? The 90 degree, equal orientation there. So equivalent orbital. But that point you have to discuss in case of the SF6 and you can. So is it possible for you to describe this sp3d2 also? I had not discussed. It's a homework for you. Could you able to understand sp3d2?
Yes, sir.
Yes, if anybody says no, then let me know.
Yes, sir.
Yes. So students, today we have discussed sp3 dehybridization. An example for that was PCl5 molecule with 7 different points. I discussed that. Now, as a homework, means additional work, this PCl5 discussion also is a homework. But additionally, you will explain which hybridization. Yes, which hybridization?
sp3d2.
Yes, an example for that.
SF6.
SF6.
Yes, this work you have to complete as a part and parcel of today's lecture. Now, one more lecture or 2 lectures we have to conduct, and whatever we have discussed, we have to wind the syllabus. If I have to sum up the syllabus, otherwise, let me see whether it is there with me or not. Yeah, it is there. It is there. Just wait. Just wait. Yes, could you see the syllabus now?
Yes, sir.
2.1 point,
Sir.
it is completed. This 2.1 is complete portion. Now directional bonding that we are discussing, and directional bonding, covalent bonding, hydrogen atoms, there's a potential energy diagram and resultant system. These all different correlation, homoatomic molecules that we discuss. Only this point I'm giving you for the homework, but later on, resonance and formal charge concept. This bonding and different hydrogen, sp, sp2, sp3, sp3d, sp3d2, up to where we have discussed. Now these 2 only are left that I will inform. Equivalent and non-equivalent hybrid orbitals, that point also we have discussed. And now last point, firstly we can cover. So remaining portion is this one, last 2 hybridization, sp2d and this one, plus formal charge and resonance concept that you have to work, because formal charge right at the beginning as a basic of chemistry you have studied, you can work on that. So next time I am going to complete the syllabus. Then afterwards, one more lecture I can give you. If you are in doubt, any question, we can have discussion. Then maybe your exam timetable will come. If not, then till that, how many days we can get question answer system will be there. Is the planning clear?
Yes, sir.
Yes, student.
Yes, sir.
Shall we stop now?
Yes, sir.
Yes, sir.
Yeah. Okay. I stop the recording.